Where does this entrepreneurial mindset came from for you?
It's a good question. I still consider myself as a scientist and driven by curiosity and trying to achieve things. But I've always been interested in going from research discovery and then do it useful things. We're now entering the next 10 years, and what we would like to do is to use this data to try to predict and model the human cell and the human tissues. I know this is very difficult, but obviously there's so much happening with AI now. It's interesting with aging because we know so much about biology, we know so much about medicine, but we don't, and maybe I'm controversial to say, we don't actually know what aging is.
So you're not a big fan of all the anti-aging therapeutics approach?
No, I'm not. No, I'm not.
Bienvenue to a new episode. I'm your host Philip, and on this show I'm interviewing the best Europeans in biotech to help you grow. Most biotech innovations were initiated in academia. One of the best entrepreneur scientists in Europe is Mathias Uhlen. He has co-founded or invested in over 26 startups, while having published 800 papers and having created the Human Protein Atlas, which is one of the most successful biology projects ever. So I caught up with him online in Stockholm. I've known him by name for several years, and it was great to finally talk live. We talked about the entrepreneurial mindset in academia. We also talked about why he's so bullish on AI for biology and why, on the flip side, he doesn't believe in anti-aging drugs. So here's my conversation with Mathias, and please hit the follow button if you're enjoying it. All right, welcome to the show, Mathias.
Thank you very much. It's nice to be here.
It's very nice to make it happen. I want, as a first topic, to talk about the 20 plus startups you've co-founded, which is a crazy number. And general question, I'm wondering how you managed to co-found so many companies.
Well, first of all, I should say that the Protein Atlas program that I have been working on now for 20 years has generated a lot of ideas. And this is despite the fact that actually the whole idea of the Protein Atlas is to be open access and so on. But actually to have all of this information also gives you good ideas about starting things. And then I should say that I am the base, my base is in Sweden. And we have a very special way in Sweden for startups. It's called the teacher's exception, or which means that we own our own inventions at the university. This means that it is, and also I should say, it's rather non-bureaucratic to start companies. So you can do it sort of in a day, and you don't have to have a lot of funding and professionals to do it. So this is one of the reasons that I'm kind of started a company every year, and it's now, as you say, it's 21 actually that I have come from my group actually.
That's amazing. Yeah. I was about to ask about I heard that Sweden with the IP has really this exception. What I'm also surprised at, what I heard your conference at BioEurope, I saw that you are investors also. You invested in many of the companies, which is also quite unusual, especially for academic. I mean, to be scientific co-founder is like quite usual, but to be as an investor. So did it help you also to own the IP, to get some more funds to then invest in these companies?
No, exactly. So one of the reasons why I did some exits early on when 3 of my companies went public, and when they went public, at least you can get some some cash out of it. And then I used that cash actually to support very early startup companies with my own money. And in this way, you can actually avoid having venture capital early on. And I must say, in my experience, venture capital is, of course, very, very important when you want to go sort of the commercial way. But before you have created the value and the products and are ready for the crazy commercial world, it's actually quite nice to avoid venture capital, I must say.
That's a good lessons there. I remember you said in your talk as well, when if you want to raise from VC, you need a very clear milestone, which was one of your lesson, which I guess correlated to what you just said as well. At the very beginning, you don't have a clear milestone from a
No, exactly.
inside
And
knowledge.
no, exactly. And I think it's very important that when you take in venture capital, you know exactly what are you going to do with that money? When are you going to do it? Will the money be enough to do it? And so on, and then deliver. It sounds easy, but it's of course not easy.
Simple, but not easy.
Exactly.
But I like that, yeah. And you I mean, some of the companies you founded, at least the one that struck my mind is Affibody, one like alternative protein based in Sweden, that's pretty advanced. I saw biotech, Atlas Antibodies. I mean, at least the three that kind of some of them struck to me. I don't know how you wanna like expand on those, or how like what makes
No,
them
no,
special?
no. Yeah, I could say a little bit about some of the companies then. So Biotage is a public company. It's on Nasdaq here in Sweden. It's more than a billion-dollar company actually now in worth. This started as with a technology from our group called pyrosequencing. Then with that funding, we also expanded and so on. So this is now 25 years ago, but we are very happy then to have sales all over the world and so on. There's another company that you mentioned, Affibody. That is not public, but it is owned by the famous Wallenberg Imperium, which is the emperor. Um, and it is now about 70 people in the company and has done successful phase 2 and even phase 3 trials. So this is yeah, and we're trying to have an alternative to antibodies for drug treatment and as drugs. You also mentioned, and then we have another Wallenberg sort of company called Atlas Antibodies. It's a spin out from the Protein Atlas, which is the academic part, where they are selling all the antibodies that we generated in the program. And this is a very successful company now, very profitable, and is selling hundreds and hundreds of vials with antibodies every day. So it's really quite nice. But then if I'm allowed to mention a fourth company, which I'm very excited about, that is a company that I co-founded in South Korea, and it is on the Kosdaq, which is the stock market in South Korea. It's a biotech company focusing on therapeutic antibodies, but also has its own program for CAR T treatments, this treatments of immune cells. And it's also very successful and is one of the few biotech companies on Kosdaq in South Korea, actually. So
How come that? I remember that one also from your presentation, and I was like, "Oh, South Korea." I mean, it's how come you were like involved in I mean, geographically, it's a bit further from Sweden, like.
No, so when we started the Protein Atlas program, the academic program, to try to map all the human proteins, we decided to make antibodies to every human protein. And actually, in the end of the day, we generated in-house 65,000 antibodies, and almost all of them were actually produced in South Korea. So and so I spent a lot of time in South Korea. I met with some brilliant people there, and one of them, Jong-soo Lee, he founded this company then together with me, and but I mean he was the main founder, and he has done some amazing stuff lately. We are in collaboration with the Chinese company Henius. We are in phase 3 for some cancer treatments and so on. And it's very I just love the passion and the work ethics of the people in South Korea. I must say it's an amazing country to work with, actually.
Awesome. Yeah. Yeah, awesome. Maybe switching a bit topic. I'm wondering where does this entrepreneurial mindset came from for you? Like for the early days.
Yeah, it's it's a it's a good question. I mean, I still consider myself as a scientist and driven by curiosity and trying to, achieve things. But I always been interested in going from, research discovery, basic research, and then try to do it useful things. And I must say this has been all the way. And I should also say that my basic training is engineering. And engineering, of course, is a little bit um, applied in a sense. So obviously that meant that but I don't know. It just started. My PhD project was to clone protein A, which is now used for purification of all the therapeutic antibodies. So already as a PhD student, I started to, file patents and so on. So it's been with me my whole career, but it's nothing that I planned. Absolutely not. It just came naturally by just saying, this is very useful. Why don't we try to, make it available for the world, basically.
But I like it's very obvious. I guess in the hindsight, it seems very obvious also that it worked. But it's also not very common. I mean, this entrepreneur mindset in academia is, and I think especially in Europe, it's quite rare slash quite missing. I think even still today, it's getting better, but it's still, I think.
No, and I agree, and I think it's for two reasons. One reason is that there is in many countries quite a lot of bureaucracy to go and start companies, and and so on. Uh, Second, I think it's not that easy, especially now, to get funding to do to form a startup and do commercializations. Um, and thirdly, it takes a lot of time to be an academic. So, you don't really have the time to do it. So I think there is quite a lot of reasons for this. But I also, and obviously one of the big advantages in Sweden is that at least we don't have the bureaucracy. And at least for myself, since I did some early exits, I could have money to support the early startups without to go to venture capital.
Mm. On the bureaucracy, I guess you also mean the transfer of the IP, etc. And not only the financial terms of IP, but also I always hear like it takes forever to spin out something from academia. For academia, it takes whatever 1-2 years to just get the IP signed and etc. I guess that's. Oh, can you expand on this?
No, 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 but it is absolutely true. And I usually say, I have filed about 100 patent families now. And I usually say that when you're ready with the publication, I could sort of send this to a patent attorney, and you can have a patent in a week, or I mean, not patent, a patent application, uh, and file it, and then you have protected your idea. And all of this is actually, it sounds very easy. Obviously, it's not that easy, but at least it's helped by the fact that it's not a lot of bureaucracy here in Sweden.
What are the trade-offs actually? Why are not more, especially European countries, like mimicking the Swedish model?
I think the trend is actually the opposite. So we used to have the same rules in the whole of Scandinavia, but now both Denmark and Norway has the same rules as in the rest of Europe, and that is that the university is only invention. I think I think the reason for this is that the politicians feel that if something is invented in the university, it's the university that should, own it. The problem with that, of course, is that a lot of the funding to the universities are still external, and in Sweden, more or less, the universities doesn't fund very much research. And I should say that when we have funding directly from the university or from the company, usually we don't own the invention. So obviously, so it's but a lot of the funding in Swedish university are either from private foundations, or they are from external, from the research foundations, the governmental foundations. Yeah.
Which I have to say also that Jens Nielsen was on the show, and I know him quite well. And I remember I founded LabIotech before, and we did one of the listing, like the top 10 scientist entrepreneurs in Europe, and you were on the list, and Jens was also on the list. But Jens told me, like, yeah, no, but Matthias is like way, 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 way better than me.
No, that actually is not true. Jens is, if this is a competition, I think that I'm actually second compared to Jens, because he is, if you look at bibliometry and, H index and so on, he is, he has beaten me actually. So I return that.
You reach him, okay. He will be happy to, if he's listening to it. He will be happy to hear.
And as you know, Jens Nilsson is now setting up this bio industry, bio innovation.
Yeah, BII, innovation.
I think it should be a model for almost all countries in Europe. It's just a fantastic achievement he's doing. But now I'm too nice to Jens. So yeah.
The Bio Innovation Institute, and that's where we recorded in Copenhagen, actually, for people curious to hear the episode. And I agree 100%. It's amazing, and it's especially amazing when you have 500 million euros or dollars backing from Novo to make the thing run and bring it out, which is a challenge when they don't have the financing.
It's a lot of money to a fantastic leadership. That's what I must say.
That's cool. On the I want one last thing on the companies you started. One thing I was curious as well is that you worked, or quite a lot of your research, I said maybe it's coming from your engineering background, but it's quite a lot in tools as well, as in
Yes.
antibody tools, sequencing tools, alternative proteins. Did it also contribute? And I'm seeing this parallel also in the US with, let's say, Bob Langer or Church or these kind of guys who have invented quite a lot of tools as well, bio tools, and who are also very entrepreneurial. Is there a correlation, as in tools research is just more adapted to spinning out, or more easier to spin out as a company?
Yeah, I think so. I think so, and it's wonderful to be compared to Bob Langer and Church and maybe Stephen Quake at Stanford. So no, but I think you're absolutely right that all the people that you talk about here, and also Jens Nilsson, we all been working with tools and technology driven and data driven science. and that just is it when you are sort of developing technology, and that's of course also true in IT and AI and so on, then it is you're on the front side of the science in that field, and that also means that there might be commercial sort of opportunities, and I think we all have sort of experienced that. And a lot of the companies that I founded is tools companies. But of course, also some of them actually is using those tools to actually develop drugs then or pharmaceutical. Yeah.
Yeah. Which is, I guess, it's the same in the Bob Langer example. Also, quite a lot of tools, but then also, I mean, Moderna was a therapeutics company at the end, and a pretty successful one.
Exactly. Yeah.
Not cool. That's really cool. Maybe switching gears to your, I mean, very connected to your research. I mean, to prepare this interview, I had a very good friend. Actually, he's at Church Lab, and he was at Nielsen Lab just before for his PhD and doing postdoc at Church Lab. And he told me, like, asked him about human protein atlas. He told me he uses it every day. It's like amazing. Uh, and I was like, wow, that's quite a statement. So and I think you must be super proud of what you have built. Like how, like, yeah, how don't you about that?
Okay, so the Human Protein Atlas started in a very dramatic way because it was supposed to be done at Oxford University, funded by the Wellcome Trust back in 20 years ago. And in the end, this was finalized, and I was, going with my family to Oxford to look at schools and houses. But then in the end of the day, they wanted me to change strategy. And the Wallenberg Foundation in Sweden then said, well, we can't give you all the money that the Wellcome Trust could give you. But if you do it in Sweden, we will fund you for 4 years to start up. Uh, and this actually meant that I stayed in Sweden and started this. And then, of course, the Wallenberg has been extremely supportive through the years. And actually, we got about 140 billion or million Swedish, no, dollars. So it's a lot of funding. And
For one project is insane. Like it's
yeah, and it has been an insane project. I mean, so dramatic in many ways. We were generating 20 new antibodies every day. We were making 10,000 bioimages every day, and building up slowly the knowledge about all the building blocks of humans, the proteins. And I'm very proud of the sort of flagship paper that came in Science in 2015. So after 10 years, and this paper has now been cited almost 15,000 times. I think it's actually one of the most cited papers from Europe in the last 10 years. Uh, Now, as you say,
my friend told me. Sorry, my friend told me this as well, and he told me that it's almost on par with the CRISPR-Cas9 paper in terms of number of citation in the amount of time, which is
yes,
crazy.
yeah, yeah, it is nice, of course, but also it is, and the Wallenberg family or the foundation, they were very keen that this is basic knowledge that we should have open access. And this has, of course, been very nice for me because now I can see that it's used by every pharmaceutical company in the world, every university in the world. And actually, every minute, there is about 10 to 15 researchers going into the atlas, into the portal. So obviously that is incredibly gratifying for what you've done. But it's also been done by a lot of people. So there has been more than 700 people formally involved in the project. So it's been fun. I I have to say.
And congrats on that. That's it. So, and now I've seen you have a new project also financed by the Voluntary Foundation on AlphaCell of basically bringing AI and AI models into the
Yeah.
human protein atlas. Can you talk a bit more about this?
No, exactly. So I guess the Human Protein Atlas program has sort of gone through three phases. The first 10 years was very much about making antibodies to all human proteins, and we basically succeeded with that and used that to create a lot of data, which is now open access. The second 10 years, which kind of started in 2015 and up till about today, was very much about integration of data and very much taking also all the fantastic RNA data, the single cell data, which is created by not only us but also other groups in the world, and integrated that with the protein data. And I think that's something that we're very, very proud of. And then we're now entering the next 10 years. And basically, what we would like to do is to use this data to try to predict and model the human cell and the human tissues. And I know this is very difficult, but obviously there's so much happening with AI now. So at least we think that we can do, we can define what are the housekeeping proteins, which are the druggable proteins, and so on. So we want to use that to actually make the protein atlas even more easy to use. And also to be able to, ask, questions like, show me all the proteins which are specific for the liver and so on, and do that in a sort of text way instead of having to use search functions. So as you say then, that we got funding for another 6 years from the Wallenberg. This is joint funding for the national infrastructure, SciLifeLab in Stockholm, the HPA, but also funding to the new director of SciLifeLab, Jan Ellenberg, which is coming from EMBL in Heidelberg, or has come from EMBL. And we're very, very happy to have him on board as the director of the national infrastructure.
I'm curious to stick on the AI and the application. We had on the show someone from Turbine.ai. We're also kind of doing simulated cells and threat experience. So how much does it to basically do drug testing and understand where can it, like, where's the best fit? How does it compare to this kind of application, or is it more the academic? I'm just trying to figure out and place it.
Yeah, I think also I'm trying to figure out where we're gonna be. So to be honest, I don't know where we're gonna be, if this gonna take 5 years or if it's gonna take 100 years. But what I do know is that we have now data on all the human proteins. We know basically the structure of them. With the AlphaFold 3, we can actually also look at the interactions between proteins. We know the subcellular localization of the proteins. The data has exploded. And I know the data is very noisy. And also we have, there's a lot of things we don't know, how the modifications, how important is that for the interactions and so on. So there is a lot of things that are quite noisy, and compared to the language models where you can actually train it on all the text in the whole world, it's still rather little data actually. Uh, so so
Especially with the complexity of biology.
yeah, exactly. So I would still say that we are I don't think that this will happen in a year or two, but uh, but still, I think it makes a lot of sense to throw the new tools, the language models, and the machine learning, and all of it in a very sort of structured way on all this data to actually start to be at least to be able to predict in some way the cell and the tissues.
And what did you think, or what do you think about the two Nobel prizes we went through, basically for AI and biology, for mentioned? Yeah.
Oh, but I love both the physics prize, which was to the machine learning and the neural networks, and the medicine prize, obviously, which and the AlphaFold. We were very quickly to adopt that into the protein atlas. So now in the protein atlas, we have all the AlphaFold structures. You can spin them around. And in the new version that came in October of the protein atlas, we also have the structure of all the variants, the transcript variants. So that's 80,000 variants. And we don't even know if they are actually true or not. But at least we are showing them, so you can actually see the structures not only on the sort of consensus protein, but also on the 80,000 transcript variants.
That's insane to me. I mean, I remember I was doing I did in bioengineering, and one internship I did it in academia, and one of the PhD, his whole PhD was on doing a structure of one protein. It took him whatever 4 or 5 years, and that was, well, not that long ago. I mean, that was like 10, 12 years ago.
No, 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 and it could have been 5 years ago. So, no, but I guess the nice thing about that is that those work, they were not in vain because you needed it to train the model. So obviously that has to, and I guess this is a very good it kind of relates to what we want to do with the cell and the expression, to use the data to actually model and actually learn about it, and in a more AI based way then. But it is crazy, and I think I'm very fond of the Nobel Prizes, both in chemistry and physics this year.
I guess you went to the ceremony though, as you in Stockholm.
Yeah. Yes, I did. Yes, yes.
It's great. Maybe you will have it for maybe where you will have the Nobel Prize one day as well.
That's we'll see. We'll see.
Have you been nominated on the once on the list?
I'm the member of the Royal Academy of Science, and obviously I can't really, talk about who is nominated and so on. Yeah.
Makes sense. Makes sense. Just curious. I'm curious also what you said. I mean, you love what you're doing, and you love the potential of AI. I'm curious on the higher level, like what really drives you, and what drives you to uh, keep doing
Yeah.
what you're doing.
Yeah, that's a good question because, I really should be retiring now, shouldn't I? But no, but I still love what I'm doing. I still have, you have to be healthy, you have to have the energy, and you have to have the lust to do things, and I still have those three things. So, but and for me, it's the perfect mix to do very basic science, try to understand how you use AI to understand about the cell, but at the same time use some of the new inventions to try to to make them valuable for the world.
Mhm.
Yeah.
No, that's sounds very good. Well, one also question on what are some of your lessons for if like the younger academics listening to us? What are some of your lessons? to your younger Matthias?
Oh, that's a very good question. Well, first of all, I should say that I've been blessed by being thrown, I guess you can call it serendipity. That means that, things happen. It might be even bad things, but that has sort of thrown you into one corner, and that has been very good. Um, and I haven't, I guess what is important is that if you get funding, that you try to deliver what you have promised. But that is not a very good advice, I guess. No, I I don't.
I
I
guess
just want.
you would recommend to academics to be more entrepreneurial, or is it a fit to their personality or to?
Well, I think it's of course very good to be able to do both, to do curiosity-driven research, but also to apply some of the things that. But I think it all depends on where you are and so on. Uh, but I of course could recommend to sort of be in both worlds. I have to say. But of course, it's easy to say that from the Swedish perspective, where it's much, much easier from a bureaucratic point of view.
Yeah, I like that. I mean, I'm also quite biased, and I'm very entrepreneurial. I started things since I'm 10. I always think, oh, people should be more entrepreneurial, but also now I realize some people are just less entrepreneurial, less risk taking. It's just also there's a personal fit, and as you said, some projects fit more to entrepreneurship, some fits less. It's not like a.
But in Sweden, we have now about 4,000 biotech companies, startups, and that's quite amazing from a very, very small country. I mean, like Sweden. So I see the interest from the young generation to go the sort of way, same route as I have done, where you do curiosity driven research, but you also try to apply it.
And actually talking also one, I mean, I have a bit to one foot in biotech, one foot in tech. And I saw that you launched a prize or the KTH Innovation Award with Daniel Ek from Spotify. It's pretty amazing that you're doing a collaboration like this. And one thing that make me think as well is that in Stockholm, I think at least in Europe, is the highest density of I think $1 million highest density of unicorns per capita, basically in Europe. Even in the world, it's pretty high as well, which I think it's connected to
No,
everything
and
we discussed.
no, and you mentioned Daniel Ek, and it's been such a pleasure to start this innovation award together with him. So we are the two sort of the two founders of this together with the Royal Institute, the university. So and it is so awarding to be able to actually also give then prizes and awards and money to people that are actually going this kind of journey, trying to go from research into to applied.
And it's amazing that you are mixing. I was really, I mean, surprised. And it's first time that not the first time, but one of the first time that I see that like a top biotech person with a top tech person doing innovation award together, which is because usually you always have like deep tech on one side and then the tech on the other side, and people don't talk too much to each other. So, can you talk a bit more about this, like, or your view on this?
No, but I don't think it is that surprising, because obviously the biotech and and the biology and medicine is so much now driven from data-driven science and AI now and so on. I have a feeling that a lot of the biotechs in the future will be together with tech people. Uh, it's just it's just the way it's gonna be. And I kind of feel that it's becoming more and more important to be technology driven, be data driven. And actually, the national infrastructure that I founded back 15 years ago, the Science for Life laboratory in Stockholm, where I was the employee number one, but it's now 1,500 people. The whole idea of that is actually to work with data-driven science and tech-driven science.
It's amazing. Makes me think about a quote, I think from Steve Jobs, who said that the 21st century will be the century of biology. Which, let's see, but it could be.
Yeah, it's so far, I think he actually sort of defined the 21st century. So I think it's amazing how he has influenced the world with the smartphones and the music players and all of that. It's just he's a big hero of mine, I must say.
That's you're answering one question that I have for you for later, but it's good. Before that, one last question or one last topic before we do a kind of quick question. But one last question is on anti-aging. I remember at BioEurope you had a question about this, and I was quite surprised on your answer, which you said basically you were saying you didn't expect life expectancy to raise way beyond 80, but that the quality of life would increase. Like, could you expand a bit on why?
Well, first of all, it's interesting with aging because here we are, we know so much about biology, we know so much about medicine, but we don't, and maybe I'm controversial to say, we don't actually know what aging is. But I think it's quite clear that, at least in my view, it is sort of running out of steam, and you're getting more and more. The cells are getting more and more vulnerable, and when you look at what has happened, the life expectancy hasn't really raised, but of course the average age has increased because we are healthier and we have better healthcare and so on. So and I don't see any good ideas how to actually increase age. So, but maybe tomorrow there will be a good idea, and then I will change my mind. But if I look at what we know right now, I don't see that we have a clue how we would, go from going 80, 90 years old to 120 or 130.
So you're not a big fan of all the anti-aging therapeutics approach at the moment, I guess. Oh.
No, I'm not. Although, no, I'm not. I don't mind that people try to live healthy. So if that is anti-aging, I think that's fine. But I think there is a lot of false promises out there, actually. But saying that, then one of my companies, Scandi Biotherapeutics, is actually starting a phase 3 trial to try to help Alzheimer patients. But it's not really anti-aging; it's more trying to help the memory of these patients. So at least I'm a little bit involved in age-related problems, but I'm not really into the anti-aging.
Yeah. Actually, talking about,
because I wish I could live for another 70 years. That would be fantastic, I must say.
it's actually talking about Alzheimer's. I mean, it's also always how you define aging. I mean, Alzheimer's is the biggest correlation to Alzheimer's is age. So is it a aging disease or not? I mean, you can discuss that. And actually, we had on the show the CEO of biotech, who's also based in Stockholm, and was doing amazing work in bringing the first disease-modifying drug on the market in the last few years. It's a crazy achievement as well. So just looping to everything we discussed. Yeah. Cool.
No, And yeah, okay, yeah, please go ahead.
Now I want to finish on a quick fire, so just quick question, one sentence answer, or yes, no answer. And before we have for the last few minutes of time we have.
Yeah.
So you said one of your heroes in tech. I'm wondering who is one of your heroes in biotech?
I must say, I have been. I liked very much Craig Venter, actually, who was, one of the, the persons that did the Genome Project. I think I learned a lot from him, I must say, and so that I think he is one of my, maybe not hero, but I learned a lot from him. Yeah.
Yeah, and he has amazing books for people listening. I mean, a lot of talks and books that are really. I read his book and was very inspirational as well, I have to say.
Yeah, no, and he was very inspirational. Another person that I really have admired is, sounds very similar, Greg Winter, who got the Nobel Prize for fixed display and so on, which from UK. He's very different from Craig Venter, but he's also kind of another type of hero for me, actually.
Yeah. He was also in the list of the top 10 European scientist entrepreneur, and I think what he has been doing is amazing.
Just mention, in the field of proteomics, we have a superstar in Europe, and that is Mathias Uhlen. So I guess I should also mention, and he's also very unique. Yeah, in Munich. Yes.
I recently learned about him. I didn't know him, and I think he's the most or the biggest H index in Germany. Any science in any science discipline is basic. And
He's just a fantastic scientist and a nice. Yes.
Next question: What's on the top of your mind at the moment?
So right now we are very much into blood analysis. So we're trying to use the information from the protein atlas and use the new developments from Sweden, Olink, where you can do massive amounts of analysis from just a drop of blood. Sort of going in the sort of the tradition of Serranos, which was a California company that was Bluff. But actually now you can do 5,000 protein analysis from just a small drop of blood. And I really think this will change the way we do precision medicine and medicine in the future. So I really foresee that we will take a small blood sample, maybe at home, send it to the lab every year, and we will find, cancers before they have symptoms and so on. And this is something that people have talked about for 30 years, precision medicine. It's really not very much that has happened, but I think with the new technology, with the AI and machine learning, I think a lot of things will happen in the next 10 years, and I'm certainly want to be involved in that.
Great. I think it's a great way to finish to wrap up and to finish the podcast. Thanks a lot, Matthias, again for joining, and I let you head to your next meeting.
So, yeah, thank you very much for letting me be in the show. So thank you very much.
Great.
Thank you.
Thank you. I'm impressed by Matthias has done in science and in industry. I'm also impressed by his enthusiasm for AI and life in general. If you have also enjoyed this episode, please hit the like, follow, or review button. Any of these actions would help a lot to give more people access to the show. If you want to see similar videos, we have a lot of them on our channel. Also, I would be curious to hear what you think. So please leave a comment wherever you are or shoot me an email at philip@Flot.bio. All right, thanks for watching and catch you in the next episode.